Then we see the idea of how to parameterize the system and the difficulty that is coming out of the parameterizing the system. And there are two cases, the same way that we did it before, minimum phase system and non-minimum phase system. We are going to do the minimum phase system, the non-minimum phase system.
We consider B, which is equal to B plus times B minus.
Then we
And
see
B
the
minus, we are going to take
general
it on
design
equal
issue
to
that I was
B0, so B0 times
that we go directly with the estimation of
plus
the system.
U. So basically,
basically what we have seen
all the
in
numerators
our calculations before, when we
B
go
minus.
from
So this would be equal to
accepting all the zeros or rejecting all the zeros, we find out
plus
the calculation becomes
0.09 something.
more attention to the count.
This would be
not as straightforward
our
when we deal
B minus.
with full
Everybody's okay
consolidation.
with this?
But we have seen that if we accept and
Now
say
we
that
have
there
some
is
compatibility
full
conditions that we took from previous
then we know that
these
by
compatibility
default
conditions.
will be also oscillating, and then there are
We have
so there are
taken
some
our time,
positive
but what is
weaknesses in every decision that we are going
what
to
is
do.
good for us is that we are
And,
going
we
to
would
decide
like to
about
see
the degree of
how we can avoid this
So we
by,
have n equal to 2. So we said again
by
that
the
S
system.
will be
The
your
second
degree
thing, we have seen that
And we
in the
selected
previous,
degree of R also.
previously when we were working, we are identifying the system,
one.
and then we identified B and A.
We did
Based
exactly
on
the
the value
same
of B and A, we are designing the controller.
So degree of R is equal to 1. We come back to R, which is equal
And then we are assuming that the signals
R
that we are
prime
getting in the
times B plus.
applications are
And my
reaching
question for you
in
is,
terms of
what
persistence
would be the degree
that they will
of
allow us to identify these values of A and B. But in real life, they could be not the case. So in real life, the way we go around it,
Why?
we inject
Why
artificial noise in the input, and we see the system can add
degree of
more,
B plus is 0, so
excitation.
because B plus here is equal to
But for mechanical
One.
system, for example, if I have
So
a
from here
compressor
we
and
can
they add
conclude
noise at
if
the
this
level
is
of the
equal to
input,
B minus,
the compressor will filter all
then
this noise.
B
We will
plus
not
is
see
equal
anything
to
of
one,
it at the level.
which means that the degree of B plus
So
is 0. So
maybe
the
you
degree
will
of
add the
R
noise,
is
but the noise is not
1.
enough.
Degree of R prime is equal to 1 means
enough
we have Q plus
persistence.
R0.
So this is why we
This
are
is the
talking
form
about
of
numerical convergence and air conditioning
Why Q
system
plus R0?
based on the identification of B and A. So basically what we are saying that since the
Monic. Monic
this
means degree
identification,
of
this,
Q is
this calculation
1,
can be time consuming
and the other one is
sensitive to B and A. Let's go and try to identify the value of the controller
Anybody has a question about this?
directly from
Any question about this?
the identification rather than
Question?
from the calculation.
So degree of S is equal also to 1.
So what's the idea? The idea is that
So
we
this implies that
reparameterize
S is
it.
equal,
So the
let's say,
system,
to
we take it
S0
as is, and
multiplied by
then we
Q plus
reformulate
S1.
it again in
And
order
then we
to
check what I did in terms of assumptions,
make
so we can
appear in the
you can follow the notes later on, just for a second.
So it becomes part of our model, and then after that we do the estimation to find the control. So how to do this? So this is basically what we are trying to do. We take the input, we take which is the control signal, we take the output of the system here, we go through the estimation algorithm, and then from the estimation algorithm we go directly with the parameter of the control. We don't have to find the value of the value of A and B. And if I put a noise at the level of the input here, the problem
assume
of
the
the
same
system
assumption.
excitation is exactly
So we are
the same. So we need
this
to
one
calculate
with Q plus
that
R1, not plus R2.
the calculation for our controllers.
It's just when you are
So how we
going
do
to
this?
review, you are going to
So first of all, what we know is that the process model is governed by A times
Q
1
R1.
is equal to B.
So when you are going to
multiplied by
review this, you will be
U.
able to
This is given.
put 1 to 1.
What is also given for us?
So what is left now? It's left for us to define what should be the degree of
the reference
A0.
model. We know that the reference model is given. We are having AM multiplied by YM is equal to BM multiplied by UC.
So degree of A0.
And from the calculation that we
basically
did,
we have said
we were
last time,
able
it has
to
be
put
equal
the
to
structure of the
degree
controller, and the structure of the
minus
controller
degree
has
of
three
plus
parameters
minus
that are known,
degree of A0
R, T, and S, according to this structure.
is equal to 2.
So
minus
the
degree
idea
of
is
B
now
plus,
work around this in order to
plus
make sure
is
that the controller appears in
zero.
the relation between Y and T.
minus
So
1,
we look to
which
the
means
characteristic
degree of 1.
equation. We know that the characteristic equation is equal
So
to
basically
A0 times
A0 is
BM,
also a polynomial.
AR prime times B minus B minus
And we are
times
going to
S
write it as
is
Q
equal to
plus
A0 times
A1.
A. We divided B in two parts, B minus and B plus, still valid. All what we have done is still valid.
Why Q
And
plus
then we
A1?
go like this. So,
Money.
so what we do, we multiply, we take
The last point that we need to
A0
cover
times
would be the
AM
value of
multiplied
T.
by Y of T. And then
We
we are
said
able to
Bm
write this as equal to
is
the
equal
same
to
thing as
Bm
A
prime
Y of T
multiplied
plus
by
B
B
minus
minus.
S times Y of T.
So
So
we
basically I
observe
take this equation
the
that we have
value
in the
of
top,
B minus
and I
T.
multiply by Y of T from both
In this
sides.
case, this is of degree 1.
Then since we have the
So
equation
basically
here, we are
our
able to
reference
know
model
that
would be
A
Bm
multiplied by
over
Y
AS.
of T is equal to B of T.
And from here we are going to
Just
write
this
Bm
here.
prime
And we continue.
multiplied by B minus divided by
So
AM.
at the end of the day, what we are
AM we
going
got
to
it
get
from
is a relationship
the specification.
that will give me A0 multiplied by AM multiplied by Y of T,
Zeta and omega n.
just equal to B minus 1 times R.
The value of B
multiplied
prime
by
last time, the
plus
way we did it,
C
is that we made sure that the gain of the system is in state
this
is equal
equation
to
here, the left hand side is completely known because it's
So
coming
since
from
this one is going
our
to give us
observer coming from the
the
characteristic.
degree 1 that we want,
The right hand side
degree
here,
1
R and S are
divided
known.
by AM,
B
which
minus
degree
is
2.
also
Then Bm would be Bm prime would be
because we say that we
constant.
don't know the system and we don't
And
want
it
to
will
know.
be equal
Everybody's okay
to
with this. So this is
where
where the problem starts, the difficulty starts. Difficulty starts from the fact that we have unknowns in B, unknowns in R, and unknowns in S. And then if you multiply B minus is a polynomial. Huh? If you multiply it by the polynomial R, or you multiply it by the polynomial S, then you are going to have a cross multiplication of parameters of B minus with the parameter of R, or B minus with the parameter of S. Okay?
So we are going to
So
select
when you
Bm
have
such
this
that
cross
Bm
multiplication
minus
between terms, the parameters are no longer linear.
divided by
Remember when we did the least square method, one of the our assumption was
in both.
linear in parameter.
And then I have to put
So linear in
beta
parameter means that
so
I'm
that
able
this
to write
is
my
all
system
equal
as
to
a regression function phi of t multiplied by theta.
So
So
we
it
select
is linear.
beta equal to
But
AM of
right now
divided
my
by B minus
the parameter theta is no longer
Everybody agrees with this?
linear.
Just to ensure that
It's not linear. So therefore,
steady state error 0.
see how we are going to do, right?
Steady state error equal to
And an example. An example. If I take B as B0 multiplied by Q plus B1,
This
and
is
I
the beta
multiply
that
by
you
R,
asked
and I
about
will
last
assume
time.
that R is the first order system.
Remember when I showed
Q
you
plus
that
R0,
what was beta?
like this. Then what we are going to have is B0
This beta is just
Q squared plus B0 R0 Q plus B1 Q.
So let's come back to our
Plus
equations to see
B1
how it works and
multiplied
how it's
by
becoming a little bit more
R0.
complicated than the previous.
Everybody's okay with this? So your parameters are no longer linear.
So we have AM. AM
There's
is
multiplication between the parameters.
minus 1.0665 times
Can you not call all of
plus
that
0.6.
This is exactly what we are going to do.
This is 8.
So what we are going to do, and we are going to
Multiplied by R prime.
integrate
R prime we said is
B
equal to
minus
Q
with
plus
R
R1
and B minus with S.
plus
But remember our
B
objective
minus,
is to
B
find
minus is B0Q
R
plus
And
B
S.
minus
and S. Not B minus times R and B
multiplied by
minus times
S, which is S0Q.
Our objective is to find
Plus
R and S.
this one.
This is our objective.
This
So
has
how
to
we
be
are
equal
going to
to
deal with the
A0.
finding B R and
A0
S.
is
This is the
Q
objective.
plus A1 multiplied by AM, and the AM is Q squared.
All right.
A1 Q plus
So
AM.
new process equation. This is the new process equation.
Everybody is okay with
We
that?
have been trying to identify.
Now I would like you to look to the
In any new
left-hand
equations,
side
for
that you
example,
have
if I
here.
write a system like this here,
just look at the left hand side.
Q
Based on
squared
our
plus
calculations of
B1 Q plus
the degrees
B0
of our R and S, we will found that this multiplication here is of
by
degree
Y.
3,
This is just an example, huh?
right? Because it is
Multiplied by Y
multiplied
of
by
T.
Q.
However,
However,
is
on the
equal,
other
for
side,
example,
we have
another
AM, which is
equation
only
on the other
degree
side multiplied by
of 2. So this is why we needed
B0
A0
plus
to
B1
make sure that the
multiplied
polynomials
by
are
RE.
on one side. Everybody is okay with this? Is it?
Look
now we
into this
understand why
equation
we're
like
using
this, I will not be able to work with it.
Right. Except that
immediately as
this
so I need to
A1 is not
manipulate it
an unknown.
differently in order to work with it.
A1 we
wait
have
a minute to manipulate it differently. We take
So we select
this
we
Q
go to
squared as a
if it's
factor.
difficult for us to do it in
multiplied by
screen,
1 plus
we
A1
convert all the
Q
powers
minus 1
desired
plus
to
A0.
into continuous, and then we take 10 times, and then we
And
take
then
to the power
we take
S,
Q as a factor here.
and then we put it as A1.
Equal to Q multiplied by B plus B1 multiplied
So
by
A1 is
B1
free. I have to
multiplied
select
by
A1.
U of T. And then
I
take
cannot
this Q
find an
squared and I
equation
will
that
bring it
defines
here.
A1.
So this will give
If
you
I find an
this
equation that
equal to
defines
Q
A1,
inverse
it means that my selection of
multiplied by
polynomials R,
B
S, and T
plus,
has to
B0
restart
plus
from the
B1
beginning. I need to
Q
increase
minus
the
1
order.
multiplied by Q.
Try to have more flexibility.
So basically what we did, we converted the polynomial from a function of Q to a function of Q inverse. And the Q inverse, we know that it's shift.
Now, if we assume
So
that
we are
this
going to write
is,
this.
since we
If
put
I
here
take my
A and
system
Y,
without this term, this will give me y of t plus a1 y of t
so
minus
we have
1
to select
plus a0
maybe something
This one is Q minus
we call this,
y of t minus 2. This has to be equal from this side.
unless we change the
Q
A1
minus
from
1,
there,
I'm
we
going
put
to keep it stick,
A01
multiplied by b0 u of t
A01 here,
plus b1 u of t minus 1,
and then we are going
which will be equal also to b0 u
Just
of t
an
minus 1
for us just to make it easy.
plus b1 u of t.
So here we are going to write it A1.
So from here I can extract what would be the value of y of t if I know all the history of y and all the history of u. So I will be able to predict what would be the value of
So what we will have here
Say
Q squared,
y of
Q cubed,
This
sorry,
is my new
plus
value. Based
R1
on all
times
the
Q
previous
squared.
history up to time t can be written as minus a1 y of t minus 1 minus
plus
b0
A1
y
plus
of
Q
t minus 2
plus A1
plus
plus
b0
R1
u of t minus 1
plus A2
plus
multiplied
b1 u
by
of
Q
t minus
plus A2 multiplied by
Everybody is okay with this?
R1. So this is the first term multiplication. If there is any mistake, just let me know.
So look at this.
Like ARX or RMS?
A1 times
It's an Alex model.
A1 times Q squared.
So, but for us, this
What
is
else?
coming from this.
Oh, the rest is
equation,
correct?
A times y equal to b times
Yes?
q. Different models later on, you can see.
All right.
later.
So the
But my objective of all what I did here is that just to show you the steps. The steps is to take the polynomial as function of q
What
and
else?
convert them to polynomial as function of q inverse.
so correct?
Identify the excess
A few mistakes.
and the
But
shift.
plus
The excess and derivatives.
B0, B0,
Minus
S0, Q
B0.
squared,
You have to
plus
find
B0,
excess.
S1Q,
Pose is going to do.
plus B1, S0.
And then from here, I'm able to express this as the value of y as part of the past history of the value of y and the past history of u. Everybody's okay with this? So for us, in order not to be
Correct.
confused, we are going to put anything. For example, if I have
Correct.
a of q.
Right, so this will be Q
equal
cubed.
to, q squared plus a1
Plus
q
R1
plus a0.
plus A1.
I'm going to say a star of
go together.
as a
We have
function
plus
of q of q
B0
minus 1, the way you want,
S0
is equal to
So this
1
one
plus
will
a1 q minus
multiplied
1
by q
plus
squared
a0
plus
q minus 2. So I took
A1
everything
R1.
out as q as a factor, I generated a
A2.
star. Everybody's okay with this?
plus B0 S1.
So we continue
Plus
then our
B1.
development. We say that
B0.
our estimates are b minus r on s.
multiplied by Q.
This system is no longer linear in parameter, but it's not linear in parameter.
Agree
and
with
we
this?
have to find the control law.
You have
This is
to
the
check
objective.
with me, you see better there. You can correct it.
And then we are going to look to special cases, minimum case system and
We
non-minimum
took
case
all the
system,
values of Q.
because they are the simplest one to cover.
So we have
The difficult
A2
ones we
R1
give them as
plus
homework.
B1 S1 at the end.
All right, so the minimum phase system, we are going to talk about full constellation. Full constellation means everything I will put in B plus, right? But I need to put it as a monic polynomial. So the only thing that will remain in B minus is the constant, is B0. You remember this, right? We did
So this will have to be equal to?
So what we have
That's right.
either
So we have-
direct solution of the Diophantine equation or modified prefix.
So this will
I'm
be
going
Q
to show
cubed
the two of these systems.
Plus
So if we go directly with the Prefontaine
AM1.
equation, this is the Diophantine equation, A0
Plus
times
A1
A0,
Q squared.
Y of t is equal to B minus R
Plus
U of t plus S times Y of t. But I cannot use it directly like this, so
AM1.
I'm going to
A01.
convert it to A star later on, we will see this.
Plus
First of all, we start
we
by
have to-
replacing B minus by B0,
multiplied by Q.
right?
Plus
And then we
I01
include B0 in R,
multiplied
and B0 in S, so it will R theta in S theta. And our objective is to find
You
this
do
R
this?
theta and this S theta, basically from our initiative. Then we define the excess poles, which is
What
the
should I do
degree of
next?
the degree of B. We check the compatibility.
What are the parameters that I need to find?
And then we convert everything to
S0, S1. So this one is one of the parameters that I would like to find. S1 is one of the
B0
parameters.
AM one. This is the
R1.
gain is to the state that we have done last time.
These are only the parameters that I need to find. All the rest are assumed to be known.
I will come back to this example later. So this is exactly the same way.
So it's turn by turn
Then I
equality.
convert, as I told you here.
And if you do the turn by turn equality, you will be able to
And
get
AM
these forms.
So this is what we did there. And this is equal to phi transpose multiplied t minus d0 multiplied by theta, where theta are my parameters. So for example, here would be, my theta would be
So you will
A1
have a
d0
form for R1.
d0
This is the
d1,
form for R1.
and the phi would be y of t
And
minus
this is the
1,
form
y
for
minus
S0
0
and
and
for
minus 1 and
for
q
S1.
minus.
As function of your
Easy,
time.
right? Simple. So this is the Diophantine equation. So basically you take all these equations that you have there and then you reconvert them
And then you have
to
computers.
Q minus 1 and then
And
you
then you have
extract your
computers.
Thank God we have
value of y of t with the
And
estimated
you are able to do the calculation with MATLAB symbolic tools. Huh?
But another way to do it is
But
to
here you
look
can
to
see what we
A0
did. And we
minus
did
1
the first time we did it.
times AM
We
as
observed
a-
everything and we said we are going to cancel and it worked very easy. It's only two
We
equations
take-
and then done.
We
For
divide
this one,
by
as soon
1
as we
over
start
A0
criticizing
times
the
theta.
system and we tried
We will
to
have
put
y
all
of
these
t
elements
divided by A0 AM.
B minus.
Divide y of t by A0 AM. I will call these two signals the filtered U and the filtered Y.
This will happen in my life.
And then I will have y of t directly of the controllers times the filtered signal. This is a cleaner
Alright.
method.
What do you mean by that?
Sorry?
The reason why it's a cleaner because the parameter of A0
Without
AM, you know
cancellation
them
means that
already.
we observed everything in B minus.
And so if you do
Everything
all
is
these
in B minus.
calculations
We did
here,
not assume anything
you
in
will
B
find
minus.
out if you start with A0 AM times y, you will end up in the right hand side
Of
of
the
the
zeros.
parameter that we
We
know.
are not satisfied with the
Parameter
zeros. We say it's created a lot of oscillation in the control, so we
Here, what do you mean by filtering action?
that filtering
so we
action.
did not cancel. But in real life, coming back to this,
I'm
you
passing
may
it
have
through this filter.
some
This is a
zeros
polynomial.
that are
It's a
good
filter.
and some zeros that are.
I'm taking y and doing the
So
same.
we are going to have still some in B plus and some
This
in
equation
B minus.
just
The calculation becomes a little bit more.
Judgment call, right?
Huh?
You.
This is judgment call.
Right.
How much you are going to accept, exactly.
So my question for you is the following right now. If I use this and I put it in the least square method, what I'm going to get?
What I did make sense? So we'd like to see the difference. So before seeing the difference, we'd like to
So how I'm
maybe
going to get
repeat the
BD
same thing that we did last time.
for R and S?
But we see if this is the right one.
Would have to, when we get the expression still there is going to be B multiplied by the initial R and the S. Then we're going to equate it to look for the rest.
How can we equate it to get for the value of B? Everybody understand my
So
question?
this is the way this
The question is clear? So we have included B0 in R kit, in R, صح? And we called it R kit. And we have put B0 in S and we call it
خزلان هذا.
S kit.
ايه صحيح؟
One of them is supposed to be monic. So what will be the B0? Right? So the value of R kit is supposed to be monic. So when you do the identification, you are going to assume, of course, R is monic, but R kit is not monic because you include B0. So you identify R kit and S kit, and the highest coefficient, or the coefficient of the highest degree in arctic, this is your B0. So basically you need to get one.
No problem.
If you get something other than one, then B0 is that one.
Yeah, somewhere. And then we'll do the same thing for the tests.
So is it possible to
Yes,
get
it's
a case
already
scenario
decided.
where we're getting different values of B0 from both R tilde and S tilde?
This is the excellent question.
So this is what we
So
did
if
last
we
time
get-
when we
if
observed
we are
the
getting the same
oscillation in the
value
control
of
signal. We had oscillation in the control, but in terms of model following, it was.
How are you guaranteed to are going to get the same value?
So
Yes, your friend is saying there is B0.
it was very nice. We would like to make it nice.
Should be the same B0.
طيب احنا الحين we said that the control signal does not contain any more
Something.
dB.
Can we find something
Last time we did it in B plus here.
Well,
And
I'm
remember
asking
B
you the
plus,
question differently.
it appeared,
Can we find
sorry,
something
R it
different?
appeared as
Do we care?
denominator.
Yeah,
So we have S over R and T over R. So when there is
Do we care if they are
zero
how much
that
is
R
a
in
stronger
the
question?
we have this oscillation in the control signal, which is making sense. Now we took it out. So usually we should not
We
see
care.
this
I'm
kind
going
of
to make a slogan. We call it in 5 to 7 we care.
Right.
Who
So if
says
you
that we
consider
don't?
no zero cancellation, this is our program here.
What does B0 do?
And I need to be fair because I think we should change it to the control
Nobody?
signal.
All of you we care?
So these are the parameters. So the parameters converge. I
So
think.
why we don't? Anybody would like to take a guess why we don't care about V0 and S? What will be the exact value of V0?
Just like select S to be n minus 2, R as n minus 1. Then we get
What do you mean? Degrees?
yeah.
Degrees 1, 1. We will not complicate it. We will not make anything variable.
If we take, for example,
For the example that we took last time, 1, 1. Yes.
If the B0 is not the same value, it will be already in S0. There is no value to
This is exactly the answer. If B0 are not the same, then S0 and S1 will change. And we don't care if they change, since they are going to change with the same amount, then the 0 that is introduced by S will not change. So in other words, we don't. Doesn't make sense? No? طيب, we have S equal to S0 times Q plus S1. And we don't know S0 and we don't know S. The 0 introduced by S is Q equal to minus S1 over S0.
So these are the parameters that I want.
So if I
The exact
multiply by
parameters
V0,
are
the 0 will not change. So if I go here and I say, for example, let's say the R
here
is basically a constant, so it's B0, just B0. So I found R equal to 1.8 in one of the examples.
So the in terms of parameters, we have
So I'm going to
convergence
say
in one
S0,
parameter, the other
this
one
is S0 till.
there is a steady state error.
And I'm going to say S0 is equal to S0 till divided by 1.8.
Now we look to the control signal.
S1 till is equal to S till divided.
This is the control
S1
signal.
is equal to S1 till divided by 1.8.
So what you see in terms of
So
change,
the value of S0 and S1 will
It's
absorb
when we
the
have
value of
the step
B0.
change.
If we try to compute the
remember
0
our
back
signal
again, you
is
will
step.
find it
So
exactly.
every time there is a step change, there is
So in terms of
change of signal.
the 0 introduced by S
and
will
then
not
a
change.
step right.
Now it makes sense?
I'm using here the step change just to show you that this is simple by simple.
So this is exactly what the algorithm will tell you to do.
So
So
it's a
basically
small
this is what we
because
have.
we took
start
all the
with
zeros and we put them
the
in the.
specification of AM and
Not in
BF
the
and
we
value
recognize
of
this.
A0.
Remember
Yeah,
last time when I told you
before
if we
phase
have a
is
non-minimum phase system and go with the negative side, it's better for me that the controller
means
see
that
me going exactly with the same way as the system.
the model
So the
structure of the
error is
plant
small.
is fixed.
So when we
Does not
did
change.
this, we improved the control signal.
Everybody understand that?
Except at the beginning when you
Assume the
see this
plan,
big
you don't know the
overshoot
plan.
that is coming,
But you are
this is
assuming
due to
about
the
it.
zeros.
The
And
model
after
is
that, there will be
fixed.
some correlation.
All the design.
So this is the presence of the zero that is on the other side. It's stable, but
So based on that, we identify what should be the
If you
value
look to
of
the
B0.
response of the
We write our system as
system,
part of
yes.
the filtered signals. Why you have
see the first time because of my initial
From
value,
here we are
because our
going
initial
to,
value starts
uh,
the zero. right?
run our identification algorithm.
Once I
that
correct it, the
will find
parameters start
the
converging,
value
then
of
you
R
see the
cube.
system is
And from the value of
going
R
and
cube, we'll
correct.
take the coefficient of the highest polynomial, we take it as B minus, we put this, we identify R and ST. This is our control. The value of T, we are going to find it based on A0, our selection here, multiplied by AM1, which is the value that we have from our.
I'm talking about the
And
zero
like this, we are
P.
going to have
B minus.
algorithm, and then we repeat the step.
This is, yani, maybe this question we can take it as a segue if we can see what was the selection of A0.
Now I'm going to explain for you just the
I took
filter.
A0 equal to
filter case.
0.5 here in this tree. 0.5.
So basically, if you would like to take an example from A to Z, you can do it like this.
0.5, which is negative, so stable, divided by capital T.
So our system we started with
So
is
S is equal to log of Z divided by capital T.
B over A
Log of 0.5
times U is equal to 1, and we selected this as
Let's do it and see
B0Q
what it looks like.
plus B1 divided
So we got
by
that
S squared
0.5
plus A1Q plus A0
divided by
A0Q
0.5.
plus A1.
This is
And
minus
then we
1.
selected the reference model, Ym is equal to Bm.
Don't try to confuse it a little bit. Because
And
we
then
need to
Ym multiplied by UC, and then we said
go
that
to
this
take it like
is equal
this
to
one is,
value of AM1
minus 4.
multiplied by Q
So
to the
so
power
this is 0.1 and see what we
Q
do. How
D0
we
is
do
equal to 1 divided by S squared plus AM1
Everybody understand
Q
what I'm
plus
doing here?
AM1. So this is our
Yes?
reference model that we have set. In terms
Anybody
of
else question?
compatibility degree, we have degree of B is equal to degree of
So I'm
B.
trying to select to change
These
what?
are
The A0, because A0 is my selection.
degree of
This A0 that we
A
put
is equal to
in
degree of
our
AM.
model here is my selection. I selected the speed as 0.5, which is almost minus 1.
Then we look to the value of B, which is equal to B0 times Q plus B1.
So now I selected
then we compute the
0.1, which
zero.
is almost minus 4.
And from here we decided that the zero can be
It's fast.
absorbed by B plus. So it
Very
accepts
fast.
the behavior of the zero. So
You
we
see
said
the
B
value of the
plus
control signal, the
B
value of
equal
the
to
control
Q
signal
plus
here
B1
maximum
over
is equal
B0.
to 2 point something.
And then B minus is
We'd
equal
like to see if we keep the same thing.
B0. Everybody is okay with this? This is what we did with the previous example. Now, according to my system here, I need to generate U filtered and Y filtered. So U filtered and Y filtered, this is equal to 1 over A0 multiplied by AM multiplied by U. And then this is the same thing. I'm going to put star here because I'm
So this is
using
the change of parameters.
the Q minus 1.
Already
this
the change of
Q
parameter is
star.
different. Right? You see the red one is not converging as fast as we want on the system.
And your states.
There is a still
The value of
some
A0.
elements still state for both.
We have the
The first
degree
one
of
is a parameter.
A0
The second one,
is equal to degree of A minus degree of B plus minus 1, and we found last time it's equal to 0, so A0 is a constant.
so we converge, but
A0
it's a
is
slower
equal to
convergence.
1.
Slower than before. Huh?
You are following what I'm doing here?
In terms
You have no
of
idea what I'm doing? Ramadan?
this behavior goes to 2 point something and goes
I'm
to
trying to
-2.5.
solve the same example that
Was
we
not
did
there.
before, but using the direct line.
This is an indication that your system is aggressively
So
trying
up to now, anybody has a
respond
question?
to the
Maybe I did
system,
some
right?
mistakes.
Before it goes to 2.2 and then comes back to
Anything
it's not
that
right, right again,
makes sense or not
just to make
makes
sure.
sense?
But keep this in mind.
يا اس كوير دي خلينا منها
And then we
كيو
see how
كيو سكوير رايت
Q squared.
هذيك واضحه هيك
طبعا هذه ما لا بلاس
صيام
صيانة.
Squeeze it to 3.
Thank you.
Squeeze it to -3.
This is why I told
You are okay with this?
This one you must
Yes.
be listening to 3. Actually,
so this is where
You
it,
have
the
what are they?
0.1, which is
Yeah, the
normally
filtered
slower
version
than
of U.
what I
So
selected.
this is the filtered U.
So the control did not change that much.
the negative side.
This is the same thing.
but the
this one.
parameter changed. So the
Basically,
parameter
they are
absorbed the
coming
change.
from my.
So this is something that you need to
These
take
are these
into
two.
account.
You add to
Ideally, it
it.
has to be as fast as you can, but it will impact a lot of other parameters that you have there. I'm using lambda equal to 1, so which
So
means
we
that
took
I'm not
this.
ignoring any one of the parameters that I have in my identification.
We took this
So
A0
I'll
times A
change this lambda
and we divided
by
all
nine.
over the left and right hand side. A0 times AM.
So I'm doing this
multiplied by
way
Y
with
is equal to this. I took
forgetting
this
the
A0 AM and I put divided here. Well, so when I divide, I will have U of T divided by A0 AM.
In terms of
and Y of
state
T
error,
divided
you
by
have
A0 AM.
smaller
I call
values.
this U filtered and Y filtered.
In terms of values of A1, A2, you have.
By the way,
to
this
have it.
notion of filtered signals, we will see it later on when we are going to move to
In terms of control,
mod reference adaptive control.
second
using
signal
MIQ.
is
We will again
smaller.
work with the filtered signals.
This one here and this one.
Up to now, everything is
The
okay?
behavior here did not change.
Yes, no?
Yeah.
Yes.
This is the one.
Alright, so we have
You have the error here.
the
goes
Differential
and
equation, we
decreases.
have A times
So
L
the
prime
error is very
plus
big at the beginning.
B minus multiplied by
You
S
can have it here.
is equal to A0 AM.
See the difference.
So
between the
if I
two, it's
multiply
around
by Y of T from
0.05.
both sides, I will have L prime multiplied by
And then
B
the more you
minus.
go, the more it becomes the smaller.
This is our equation
So
here.
here to this value.
Repeat the same calculation
Plus
again.
1. And if we go a little bit more. So the system
We
goes
have B
and
minus
improves itself. This is what it means. The system is going and improving.
A0 AM multiplied by Y of T.
That is the value. Everybody is okay with this?
B minus.
So our algorithm is exactly the same way. We did it last time. We first
Plus
start
S
with
multiplied by
the
Y.
estimation. So this is our estimation part. So this is our loop in terms of time.
So in this case, B minus is equal to B0.
So this is our
I'm going
reference
to call
model.
this
that we
all
have
as
created
RT
here.
multiplied by
And
Y of
then,
T.
after that, we
plus
start
ST
looking to
multiplied by
the identification. So here
And
I'm
if I
using
take this
number of cluster 4.
and I bring it to
I'm
the
using
right hand
P0
side,
and
I'm
P,
going to write Y of
so
T.
it's a diagonal with
is
100.
equal
You
to
can play with
RT
this and see
times
also the impact,
Y
the
filtered
parameters. If we change
plus ST
the value of the
divided by
factors, we start the loop. So the
Y-
loop starts
Y
with
filtered.
generating all the previous values.
So
of
the
this,
RT
and then we create
is
the
equal
output
to
with an
V0.
assumption of our initial input. So this is our initial control with our initial parameter.
multiplied by
Once
R
we have
prime.
done this, we identify what are
And
the
in our
parameters
case, our
of
value
A
of R
and
prime is equal
we
to
identified A1
1.
and
So our field is basically B
And
plus.
then we fixed our reference model. This will be out of the loop
So if I identify R field, this
because
is the
it's
value of B
constant.
plus.
It's only one time, so I don't need
So
to do
based on the fact that R prime is equal to
I compute all the numerator and denominator, and I multiply it by beta, and beta we said is equal to AM1 cubed, AM1 of 1 divided by.
and then we have S tilde
0.1, B
is
minus
equal to
one.
S0 times B0 times Q plus
From here I
S1
define B plus
minus
equal to 1, B minus equal to B0, B1, B prime
negative,
is
so this
equal
one
to
SQ0
beta, and then I put here A0 is equal to 0.5 multiplied by
This is the value.
A0. Multiplied by this. Control signal. After finding the control signal, we find U. We come back to the first line of control. And we
Okay
continue.
with this?
Right? So basically the algorithm,
R tilde. R prime, not R tilde.
the algorithm is something like
So in our case here, the value of R is based on this equation that you have here. The same development that we did before.
The equation in the slide is B0 not R prime.
Yeah, because we are assuming the equation.
so we start with BMAM, which is the design. We compute what should be the value of the observer A0. This is our selection. We use the recursive discrete to estimate A and B. We compute the polynomial RMS using we compute T, which is A0 Bm prime. We compute U, the control, and then we come back.
So we have here, this is B plus. And B plus is null, right?
Any question about what I did here?
So R prime is equal to 1, so this
All right, are there some variant of this control?
B0 plus B1.
This control up to now we did not assume disturbance.
If you are prime is equal 1 for the degree.
So what will happen if we have disturbance?
But the fact that we multiplied here by B, we took one of the B plus, we put it with R
So
prime.
let's look at this.
So this is why it became only B minus. So and this becomes R.
This system is with disturbance. See what type of disturbance we are going to.
So why I'm doing all this with you is just to give you the two filters that we need to implement, because at the end of the day there are two filters. The first one is how to compute U filtered and Y filtered. So U filtered is equal to U divided by A0 AM. I'm going to put star here again. So just basically U divided by A0 we said is equal to 1, AM star is equal to 1 plus AM0 Q minus 1 plus AM1 Q minus 1. Right. So this is the relationship between U and
So we have two types of disturbance that we are
So
going
if
to
we
consider.
take this
I'm
and
going to start with the
multiply it with the
normal
left
distribution.
hand side, you are
And
going
then
to
we'll
have
see how it works. So basically what I'm assuming,
Plus
I'm assuming
AM1.
the system has
U
the
of
disturbance
T
at the
minus
level
1
of the input
plus
is
AM0 U of T minus 1
and
U of T minus 1
randomness that I'm going to assume
is
is
equal
leverage
to-
equal to 0. So it's 0 value.
The U is
zero
on the
value
left are filtered.
to the,
U
the signal. And the balance equal to
Is equal to
1 square.
Everybody's okay with
This
this?
is the standard
So
deviation.
from here I can conclude that U filtered at time T.
The rest is
basically
exactly the
equal to
same thing
minus
that we
AM0 U filtered at T minus
So if
1
we run this,
Minus
it's
AM1.
going to be that.
U filtered at T minus 2 plus the value of U at time T. So I take the value of Y of T. I take the two previous values of U filtered, and this will allow me to generate the new U filtered at time T. And this is the one that I need to use for the equations that you have here.
For the first step, first two steps.
First two steps you have to
Zero.
assume 0.
So this signal is as before.
Zeros or a shift, which is
So
basically
this is
0 or
the
if
case
you
that
have-
we used at the beginning completely when we consider it.
AM0.
In terms of output,
Yeah, no.
we have the nice
Yeah.
output as before.
What was the use of this whole formula? Should I know?
To calculate
You
In
can
Yes.
calculate
terms of
the-
convergence,
Because you filtered, you have to put it here.
we have a
To
very good
find our
convergence.
tilt and
of
this
that.
tilt.
So I would like you to take a photo of this if you
audio
don't mind,
controller.
and before we go to the zeros.
Makes
Everybody's okay with this? Now we go and we add the noise. Now the noise that I'm
So
adding
this
is
brings me
just a
to
little
the
noise, but the average
program.
value is
I would like to show you the
zero.
code so you
So
can
I'm not
understand exactly
using
how
the
this is
script.
working.
the
So
same.
every time we have a filter is basically we write it in the form of
The average value is zero.
differential equation.
So this is the way the parameter now are conversion. So this is the value of B. The value of A and B. And so the value of B absorbed some of the changes, but the value of A seemed to be okay, except in terms of output.
Alright, so we do exactly the same thing.
Here on the system. This is your reference model, the green one.
So we take
And then the blue is your reference. So this is your reference model. This is your reference. Like you see the effect of the noise, which is introduced here. Yeah.
this is our reference model.
Right? In terms of average, since we assume that
Our
the
reference model is
noise has an average equal to 0, we were not that far from the reference
We
model.
are simulating up to 100.
طبعا we can make it worse. Here we are assuming. an
Here I'm
amplitude of
generating
1.
the disturbance, you forget
But
about the disturbance.
the standard deviation of the noise is
So we take our
0.1.
system, which is
So,
E over
noise to signal ratio is around
continuous.
10 times.
We convert it to discrete.
But if it was
and from there I
more than
extract
10
the
times,
discrete
for
system.
example, if you take
And I
0.5
extract the excess
as a standard
number of
deviation, then you are
points,
going
which
to
is
see
zero. I can
huge
here I'm
change.
doing exactly equal to 1, but I can.
So this noise
see
can come
the
from your
size
measurement or can come from anywhere
of the
else.
vector
And now if we go and we see
decide by the size of the vector, what's the degree difference. I extracted what is exact
the
in
constant
terms of
noise,
parameters.
the constant
And then
disturbance.
I defined here my BM over AM. So I took omega n equal to 1, z equals 0.7.
So the same amplitude,
created a
0.1,
continuous system,
but I'm using a
multiplied the
constant,
continuous system based on
constant.
the
It
constant
means
period.
the
After that,
disturbance
I
is
took the whatever MATLAB
consistent.
give me, I know the numerator.
consistent,
MATLAB will give me a numerator.
consistently introducing the drift.
I
Always
know
there.
the numerator, and I
It's a
include the
constant.
numerator by only the value of the sum of the denominator, which is A of 1, AM of 1, as we have said it last time. So from here I extract what should be BM 0, BM1, BM0 should be 0, only BM1 is different. Identify the number of aggressors equal to 4. Lambda, we are putting it equal to 99. I'm going to put it equal to 1. And then continue. Lambda equal to 100. I need initial values, as your friend pointed out, because there are some shift in time. So I need to have the value of A0. I need to have the value of theta 0, which is A0 multiplied by AM1 is constant in this case. I take the value of the parameter of B and S random, and then I
B and S. Then parameter. Yeah.
are tilde and still. Then we take initial value of Y and Y filter because we have one regression in time. I can generate one initial value of U and Y and one filter based on this regression, but this is basically assuming that t minus 2 is 0. And then I start my loop. And then the loop here, I have some work that I did, which is including the disturbance at the level of the input, so we ignore it. But this is the value of my controller based on my initial values of R1, R0, and T1, and the 0 S1. From here, I calculate the filter based on this U, and the filter, you see, it's the same equation that I did there. Right? So filter, which is just a recursion. Then from there, I get my Y estimate based on R0 multiplied by R tilde, or R tilde values and this tilde. I use the error, which is between my estimate and my output. This is my error. Then I generate my regression vector, my value of k for the least square method. I update my P0, computed the new value of theta. And then once I have the new value of theta, I need now to come back again from the beginning of the loop, from here. Right, so this is for my next step. And then it's a plot in the data. Everybody understood the code now? So the code, implementing the filter, there are many ways to do it in MATLAB, but we want one that can do it point by point. So there is a MATLAB function filter that allows you to create any filter you want, but we just use the equation. So these are the values of B's. They have been correctly identified, B0 and B1. These are the values of the S0 and S1, also well defined. Don't look to the eyes, because this is the same code that I used from the previous algorithm. So we are not identifying A and B, we are identifying the R tilde and S tilde. And from here you can see the controller is exactly the same as we had before with the ringing. The same thing. Now if you look to the performance in terms of time, this is the performance in terms of time. So the initial values going up to the sky because of the initial values, but after that we have perfect model following. And in this algorithm I did not compute any value of the process itself. A and B are not known for me.
That's the question. Why would we choose this method if it limits let's say choice of the zeros. Because we're not taking any zeros. Yeah, b minus is only constant.
Yes.
So we're limiting ourselves.
So what will happen if b minus is not a constant?
We will not be able to.
Non-minimum phase.
Huh?
Non-minimum phase.
No,
No minimum
RT,
phase. But what will happen in all our algorithms that they show?
RT then still will be say bigger, and we will not be able to identify B0 directly.
So let me go
Maybe
back to
change
what
the
I did
vector.
and B did, and you tell me what will happen. Huh? I would like you to think about it. Suppose that I don't cancel any zero. I put all of them in
B minus.
B minus. So I have RT will be equal to B minus multiplied by R. طبعا all of them star. Huh? We are talking about Q to the power minus something, all these polynomials. And S tilde is equal to B minus multiplied by S. So what will happen with all my calculations? Now B minus is not a constant anymore. It is a
Polynomial.
polynomial.
So you get the first coefficient, but the other two, the other coefficient is hard to get.
طيب, okay, this is one way.
Change the filter.
Change the filter.
Or replace the filter to match in with UT and SL.
Okay, but I have no idea what B minus is.
Yeah, the identification.
We don't know what B minus is. So B minus is something unknown. We said that we don't want to identify B and A. At least up to now. I'm going to change it later, but I want to find B and A. So how am I going to deal with this? For this one, it's easy. B0 is the coefficient of the highest power. It's easy to extract it, and then we continue, as your friend said. But what if B minus is a polynomial? What we have to do? First of all, the good news is that we can apply the same method. Yeah? That's the good news. So you are not confused. And we are not limiting. But now I'm asking you if you were the one presented with this problem. This one here. Where B minus is a polynomial and you are computing R tilde and S tilde with B minus times R and S. How can you continue the system? Or how you will deal with the system? What will change?
Easy.
Anybody would like to take a shot? How he will proceed?
Trying to finish.
I can assume it's Ramadan. It's okay. So what we do, we continue the procedure exactly the same. We don't change anything. Right?
What about the degree here?
The degree will be higher.
How do we separate them?
How do we separate them? This
Yeah.
is the question. We separate them by doing the following. We compute
Assume for
the zeros of RT. Compute the zeros of RT, and we compute the zeros of
still.
ST.
We'll find that the same zeros
The same zeros
are
are
the B.
RB minus.
But theoretically, they can have
Different.
the same zero, but it would not be. B.
R and S can have
Can have one
common
one
zero.
common zero,
Can-
except
Yeah.
for
We don't care.
we don't care
No, no.
How-
because we will take it off. It will
How
not
will
be in the
you share?
controller.
I will take it off. It will not be in the controller.
It doesn't matter.
I will not have oscillation in the controller. This is all what I want.
Yeah.
The controller is stable. As long as the different equation is equal to each
Holding,
other,
yeah.
the dynamic that I want is coming. I'm having it, sir. Right? If you have A times R plus B times S is equal to A0 AM times BC, always very valid, then you are getting AM, the model that you want. The question is what's the quality of your controller? The signal, the input. So I need to take from the controller, I need to take out of the value of R and the controller all the zeros that I will judge underdamped. And for me, the underdamped would be the common zeros between R and S. Right. Are we going to get them exactly equal? With the identification? No. So we may find that if I look at it in the absolute value, there is no common zeros. So I need to put a margin, threshold. If they are less than this, then they are the same. Everybody is okay with this? So this is part of our work as a control designer. Yes, you have a question?
I was going to ask if, for example, if we compute the zeros of RT and ST, we find, for example, 3 common zeros, and then we have B minus, the degree of B minus, for example, is 1 or 2. How can we get the?
There is an issue, huh?
Yeah.
So the real answer then, for some cases, we are going to be stuck because we are going to find probably contradiction between what we assumed and what we are getting. So the way to go around it is that we mix the algorithms. Mix the algorithm means that I will create a hybrid algorithm. The algorithm is not fully direct and it's not fully indirect. So I will use what we saw last time to estimate B and A, but I will not do any calculation in R and S, and I will use the value that I'm going to get in B and A to compute the value of R tilde and S tilde. Everybody understood that? خلاص أنا كملت اللكشر. All the slides they are talking about what we said right now.
I don't know homework.
Sorry. So basically this is what it is. So we are going to talk about so all these conditions have to be verified. They have to be consistent in my work all the time when I'm getting all these values. The filtering is very important because it allows you to remove also some kind of anomalies in the data that you have in here. This is the example that we have seen before. So the algorithm is, I will come back to this data, how to compute but this is what it is. We are going to compute the value of RT invested, and this is the case of non-minimum phase system. And then after that, we cancel common factors between R and S. These are considered to be the B minus that you have here. Right? So this is one way to do it. The other way to do it is to mix the algorithms. So we use the algorithms to find A and B. By knowing B, we can compute B minus. So we know B minus from the beginning, and then we try to take it out from our equation of the estimation. Right. Now, in our algorithms, we are computing the value of R and S, and then T is given directly by our calculations. We are also able to include T in the identification. So we no longer value, but this is easy, right? We just add T as part of the equations that we have. So basically, we add T here with UC, we compute the error between the two. And rather than having the equation Y as function of U of T and Y of T, we will identify based on the error between Y of T and Y error. And T will be here. So T becomes part of the identification algorithm. It's one of the parameters that we need to identify. Does it make sense what I presented for you here?
Yes.
It does? All right. So this is exactly what we'll cover, and we'll finish this topic of recursive, not recursive, sorry, but polynomial controllers or RST controllers. What I'm expecting from you right now is to apply this. So we have two ways to do it. Either you take your algorithm and you modify it, and you put the new system and you try to see it. And I believe if you are able to program it, means that you understood the algorithm. So you are able to solve any other system, right? Because programming means that you put your ideas in orders, right? And if you put your ideas in orders, any problem after that is easy. And this is why I'm asking you to program, but I have the program and you have them also in the book. But it forces you to understand the steps, and this will be beneficial. So I would like you to reprogram the problem 3.6, the same problem that we did here in class, assuming that you have B minus cancelled or B minus not cancelled. Put it direct and indirect at the same time, and this will be your assignment for next lecture.
3.6.
The same problem that we did. You open the slide, the same problem that we did here.
Yeah.
Use it. Use it.
By direct and indirect.
Yes, because you have the results also on the slides, the curves, so you are able to see if you are doing this correct or not.
For what session?
Sorry?
For what session?
The
Deadline next week, as usual. 1 week. Not 1 week and 4 days and 5 days and another week. Okay? Only 1 week. 1 week, you change your program, you just add the design parameter in the program that you sent me before, and then you open. You have the same algorithm in the book, by the way. Look into the book, look into the algorithm is fine with me, as long as you understand the sequence. You are able to solve any problem with that. Alright? What I will do with you next time is, I would like to ignore everything about identification. I would like to do adaptive, but without identification. Right? So I don't want to do identification at all. And we are going to start, right now we are working with input-output systems. So we are focusing on Y and U. So next method that we are going to see will allow us to find adaptive controllers without identification at all, completely out, and from input-output point of view. So still we are looking to single input, single out. Everybody's okay with this? Later on, we are going to ask the question, what happens if we have multi-variable system? And then we move to Lyapunov-based design. Is it clear what I said here?
Yeah.
All right. خلاص. Thank you very much. See you inshallah Sunday.